What's up, math scholars? We're doing 10-3 day 2. It's pretty much what we did in day 1 with using the identities to substitute and cancel and substitute and cancel till you get where you need to go. So it's really along the same lines today. All right. So when we start off, I'm just going to kind of talk. You're going to basically be using the identities off the sheet to verify new identities. When you're verifying an identity, you'll begin to work with one side. You'll be always working on that one side until that one side you're working on matches the other side. So that'll make sense in a few slides. But before we get into actually doing those verifying problems, I want to write down some other versions of the famous Pythagorean identity. Other versions you might see pop up today. So the most basic Pythagorean identity we use the most often is sine squared theta plus cosine squared theta equals 1. You'll see that more often than any other identity. But I'm just going to rearrange it to give you alternate versions that you might end up using, kind of like we did in that homework problem we went over. If I would take this identity and subtract the cosine squared theta over, I would have sine squared theta equals 1 minus cosine squared theta. Do you agree? So this is just an alternate form of the same identity that you can use to solve. All right, let's go back to the original. What would happen if I would subtract the sine squared theta to the other side? Well, it would solve it for cosine. So this is another version of the same exact thing. We'll be using a couple of these today. That's why we're doing this. Or maybe you could even add it onto the little sheet if you have room on the back or room on the bottom edge or room on the side. And then the last one we're going to write down that we will use today actually solves the identity for negative sine squared theta. So if I would take this sine squared theta and subtract it to the other side, I would have a negative sine squared theta over there. And I would bring this 1 and subtract it over to the left side. It would be cosine squared theta minus 1. That ends up getting used today later on. Thanks. All right, go ahead and jot the problem down. I'm going to write our strategy off to the side that you don't necessarily have to write down, but it'll be here so you know what we're doing. We're going to work on the left only. We're going to be making some, substitutions and cancelizations until it matches what we see on the right, and then we'll be done. It will be verified, and we'll do a big check mark when we match, when the left matches the right. Does that make sense? Okay. All right, so let's start with this one. Oh no, I was going to try to replace the top with something, but I changed my mind. What we're actually going to do is split this into 2 fractions. It'll be easier that way. So we're going to take this secant squared theta and put it over a secant squared theta. And we're going to take that negative 1 and put it over a secant squared theta. So I kind of took that fraction, just split it into 2 separate fractions. You're allowed to do that, as long as both the numbers confused. All right, so basically this guy gets that denominator, and this guy gets that denominator. And they're 2 separate fractions. Let me give you an example. All right, we're not working on the right-hand side, only on the left-hand side. We split it into 2 fractions. I had a student that recognized our secant squared over secant squared gives us 1, which was awesome. I'm going to go ahead and focus in on 1 over secant squared. Is that on your sheet at all? 1 over secant squared? It is not, but the concept is, and the concept that I'm looking for is the concept of secant and cosine are reciprocals of each other. Secant and cosine are reciprocals of each other. So what I can do is reciprocal this and just call it cosine squared theta. Does that make sense? We're not working on the right, we are only working on the left. Do you recognize this from maybe, I don't know, 5 minutes ago? 1 minus cosine squared theta. Let's go back and peek. 1 minus cosine squared theta. Do you see it? Right here, 1 minus cosine squared theta. So that's why we did that prep work. We kind of just rearranged our identities so we would recognize things. So 1 minus cosine squared theta equals sine squared theta. So at this point, we're done. We literally just say check mark because we have verified the stuff that lived on the left matches the stuff that lives on the right. All right, go ahead and jot this next one down. Just a quick reminder on our strategy. We're working on one side only, not working on the other side. I guess it's really up to you if you're going to work on the left or the right. I'm going to stick with the work on the left one on this. We'll work on the left and make our left match our right. Right, I would definitely probably start with thinking about this cosecant. I'm sorry, I almost said it. Who is secant reciprocals of? Cosine. So let's just flip it upside down and call it 1 over cosine instead. And how do you think we could replace that tangent? That's an idea. There's another thing on your paper that's a better idea. Sine over cosine. Yeah. So tangent, you always have a couple options. You could do the 1 over cotangent, but you could also do sine over cosine. So I'm going to go with sine over cosine. I'm not working on my right. I'm leaving it be. What I can do to save writing is just do dot, 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 dot to the very end, and then just write it again at the end. All right, what we have here is 2 fractions that have common denominators. That's awesome. We're going to put it in one big fraction together. This is almost reverse what we did in the last problem. So we had common denominators, so we put it all together in one big fraction. Okay. All right, the next step is a trick. Sometimes people just use little tricks to make these work out, and you just have to kind of pull the trick out of your brain, and the more you do, the more good you get at coming up with these little tricks. I looked at the final answer, and I saw that my denominator was a 1 minus sine x. So I was like, all right, why don't I multiply by a fraction with that denominator, 1 minus sine x, and see how that would work. Now, whatever you do on the bottom, you have to do on the top. It's kind of like a math rule. Keeps the multiplier having a value of 1 and doesn't change the value of your original fraction. All right, at this point, we have a little foiling to do. Blah, huh? Now, we're not going to FOIL the whole thing because they're conjugates, so we really have to do that matchup and that matchup. 1 times 1 is 1, and sine x and negative sine x is negative sine squared x. Now the bottom I am not going to distribute or FOIL or anything. I'm just going to leave it, and you'll see why in a second. It's because somebody's going to cancel. Again, we're not working on the right. You can just carry him on down the whole way. You see it? Maybe. Do you guys recognize, this might be what Andrew sees, do you recognize what's in this pink box at all? You do? From earlier? That's awesome. What does that pink box equal? Cosine squared x. Sweet. So what's in the pink box is actually cosine squared x. Let's put theta. And on the bottom, we've got cosine x and 1 minus sine x. It's not that there is an answer, it's just we're trying to make our left look like our right. Do you see how we have 2 cosine x's on top and 1 cosine x on bottom? That means one of the 2 will cancel. So we'll have a cosine x on top, one of them, and a 1 minus sine x on bottom. And now my left looks like my right. Awesome. So this one is harder than any that I would give you, and mainly because we had to come up with that really random idea of multiplying by the denominator of where we were headed. And yeah, it's verified. All right, we did locate our last one. My apologies if this is the same exact one as last week. I don't remember for sure, but it won't kill you to do it again. All right, let's talk who we should replace first. Who do you guys think we should replace first? Cosecant would be 1 over sine. All right, and maybe we'll replace tangent as well while we're at it. What does tangent equal? Sine over cosine. We're only working on the left. We're not working on the right. We're trying to make the left match the right. All right, what do you think is going to happen?
We cross multiply. Nope.
Cross cancel cosine, cross cancel sine, and now our left matches our right. So we've been verified. Okay. So we are going to go ahead and be done. We are all looking outside because there's a terrible storm coming. It's dark as midnight outside right now. So hopefully no tornadoes come.
Marty, those are yours.
Here's your homework. Thanks for watching the video.